Welcome back everyone to Learning by Teaching. Today we're in dynamics and we're going to solve problem 12.49, okay? It says, the jet car is originally traveling at a velocity of 10 meters per second when it is subjected to an acceleration shown. Determine the car's maximum velocity and the time t prime when it stops. When t is equal to 0, s is equal to 0. Okay, so what we have in here is that we have this car and they're giving us the acceleration versus time graph. And what we can see is that we have an acceleration of 6, constant of 6, all the way from 0 to our time 15 seconds. And then from our time 15 to our t prime, we'll have a deceleration of -4. Basically, if we put it into like real life context, the car is braking, okay? So in order to solve this problem, what we need to know is that our acceleration is equal to the derivative of velocity with respect to our time. And since our main goal is to find the velocity, therefore we need to solve for our change in velocity. So let's solve for our change in velocity. Has to be equal to our acceleration times the change in time. And if we perform an integral on both sides, so if we do the derivative of the change in velocity, has to be equal to the integral of our acceleration times our change in time. And then we will be able to solve for our velocity, okay? So if we start from 0 for our time all the way to our 15 seconds, what we know is that our acceleration is equal to 6 meters per second square, and it's a constant. So knowing that, what we can say is, okay, we're going to do the integral of our change in velocity. Well, the change in velocity boundaries go from our initial velocity. Do we have an initial velocity? Yes, we have an initial velocity of 10 meters per second that the problem statement is giving us. So we got 10 all the way to our final velocity, okay? And this has to be equal to the integral of our acceleration. Well, our acceleration is 6 multiplied by our change in time, and then the time starts from 0 all the way to 15 as we stated in here, okay? So now if we do the integral on our left side, we'll have that the integral is just v evaluated from 10 all the way to the final velocity has to be equal to 6t. That's the integral of our right side, which is going to be evaluated from 0 all the way to 15. If we solve and we put our boundary conditions in our left side, we'll have v minus 10 has to be equal to 6t. So what I'm going to do is I'm going to change this 15 to a value of t because I want to leave our equation in terms of t. So this will be equal to 6t minus 0, so I'm just gonna leave it as 6t, okay? Then I'm going to solve for our velocity, and our velocity should be equal to 6t plus 10, okay? And then this is valid from 0 all the way to 15 seconds, okay? For our time being 15 seconds. The reason why I put 15 in here is that that's the last second that I have in here. And what does that mean? Well, if we take a look back into our acceleration, in here is where we start braking, meaning that the maximum velocity that I'm going to find is at our 15 mark, our 15 second mark. So if we do that, velocity when time is equal to 15 seconds will have be equal to 6 multiplied by 15 plus 10, okay? Therefore, if we plug this into our calculator, we will realize that this is equal to 100 meters per second, okay? And we just found our first answer for the question. The next thing that we have to look is the t prime that we are looking when this car stops, okay? So what we need to do is we're going to do the same process that we did in here, but for our different time, okay? Starting from 15 all the way to a t prime that we don't know how much it is yet. So if we do the same, we're going to do the integral of our change in velocity has to be equal to the integral of our acceleration multiplied by the change in time. But in this case, we have the integral of our change in velocity. Well, our change in velocity for this specific time, this 100, will be the initial condition, meaning that our initial velocity will be 100. And then our final velocity will be just final velocity, we'll just call it v, okay? Just to simplify things. And then the integral on our right side, well, what is our acceleration in this time? Okay, so let's take a look. So in here we have -4 when our time is between 15 and t prime. So I'm gonna have that between 15 and our final t, we have an acceleration of -4, and we multiply this by the change in time. Okay, so if we solve the integral on our left side, we will have v evaluated from 100 all the way to our final velocity, and then we will have -4t evaluated from 15 all the way to a final time. Okay, now if we apply the boundaries on our left, we're gonna get v minus 100 has to be equal to -4t minus, and then -4 multiplied by 15. Okay, and then if we solve for our velocity, we'll have that this is equal to -4t plus 4 times 15, which is equal to 60, plus 100. Let's not forget that this 100 comes from our left side. Okay, so we can simplify a little bit more. We got -4t plus 160. Now that we know the equation of velocity, what we need to take into account is that we want the time when our car stops, meaning that the velocity is 0. So if we put that our velocity is 0, and then we have -4t plus 160, and we can solve for our time. Well, the time will be equal to 160 divided by 4. And if we put this into our calculator, 160 divided by 4 will be equal to 40 seconds. Okay? And this should be our second answer. This is our t prime. I hope you guys liked the video. Please push the like button, subscribe, and I'll see you guys in the next one.